Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our course. In this course, we are going to learn how to build a basic movie recommender system. First, we're going to load in data about movies and ratings from users about those movies. Then we are going to convert that data from a CSV file into pandas data frames. We're going to learn how to work with data frames, how to clean them, merge them, manipulate them, and more. Then we're going to build out a correlation matrix that uses SVD, known as singular value decomposition, and that is going to be our recommender. So it's going to be quite an easy way to build a recommender very fast. And then we're going to put the recommender to the test, and we're going to see, can it predict us accurate movies to recommend a user. So we're going to be able to put in a movie, and the recommender will tell us the movies that have the highest correlation to our example movie, and those would be the movies that we would recommend to the user. And we're going to be using a correlation matrix that uses the user ratings of all of our movies in order to find the correlations between different movies. Very fun project, very accessible for beginners. All that you need to get started is some Python programming experience. So we will include for you a section called Introduction to Python, and that's a prerequisite section. So if you've never coded in Python before, then watch that section. Otherwise, you can skip right ahead into the recommender section. As well, we're going to be coding in Google Colab, so you won't actually have to download or install anything to take this course. Very accessible and fun, so join me coming up. We're going to get started in our next section. Hello everyone, and welcome back to our course. In this lecture, we are going to get started building out our basic movie recommender system. Our first step is going to be to load our data as a pandas data frame into our project. So join me at Google Colab, where we'll get started. Just go to the link colab.research.google.com, and this will allow us to code in Python online. Now, I've included for you the data that we're going to be using in this project. You can find it just in that first lecture of this section, as well as in the last lecture of this section in the source files. All right, so if you are interested in seeing the data for yourself as well, you can get it at this link alternatively. So you can either get it from the lecture file, where it's in a zip file, or you can get it from the actual source of the data itself, which is Group Lens. The data set is called Movie Lens, and we're specifically working with ML latest small. All right, this link will prompt you to download the zip file immediately if you'd like to do it directly like that. You can also visit the source of the data at grouplens.org/datasets/movielens/latest. This will allow you to actually see what the Movie Lens dataset is all about. All right, and here below, I've included a code cell in a comment, so it won't be compiled because it's a comment. And this is just a reference to the creators of the data. It was scraped from the Movie Lens site, and it scrapes information about movies, information about users, and information about ratings that the users made of the movies. Awesome. Okay, now we're going to click on this folder icon, and we're going to pull in the data files that we're going to use for this specific project. So we don't actually need all of the files in ml latest small.zip. In the source code for this project, I've included for you exactly the files that we're going to be using. We're only going to be using two of them, and they are movies.csv and ratings.csv. So just pull open the file where you have it on your computer, and here you'll see I've included it for you in this lecture 00 data. We're going to take movies.csv and ratings.csv. We're going to take both and we're just going to drag them right here and drop. We'll get this reminder that uploaded files will get deleted when this runtime is recycled. That's fine. That's going to upload the CSV files here into this project. That means they'll be available for us to use as long as the runtime hasn't been cut. So if you do refresh the page or you come back to the project another day, you'll just have to re-upload these files. The other option is to use TensorFlow to get these data sets, because TensorFlow does make these data sets available as well. So if you like, you can do that. You can use TensorFlow to grab the data sets. I'm doing it directly this way to ensure that the project is going to work with this exact data, because if you have an older version, a different version, or even a newer version of this data, then the project might not work because the data could be different depending on which one you actually have. So to make sure that our project works, I'm just going to hard code in our CSV files. Okay, awesome. Now, coming up, we're now going to take that data, those CSV files, and we're going to turn them into a pandas data frame. So join me here. I'm going to create a new code cell in CodePen by hitting plus code. And I'm going to start by importing the pandas library. Then I can use a function of pandas known as read CSV. This allows me to take a CSV file, such as movies.csv or ratings.csv, and I can convert them into the pandas data frame type, which is going to allow me to work with them much faster in terms of processing, and it opens up a wider range of functions that we can use on our data. So for this function read CSV, we have to pass in several arguments. Starting off, we're passing in the actual name of the CSV file, ratings.csv. And as well, we're going to pass in here a separator and our column names. But first, let me just show you what we have here on its own. So the result of this is going to be our ratings data frame. And I can paste out for you that variable to see its contents. Note that I just passed in the string of my CSV file, and the only reason that works is because ratings.csv is directly inside of this files folder, which means they can be accessed directly. All right, so I'll run this code cell now, and look at this. We get here our data frame. We have our different columns, user ID, movie ID, rating, and timestamp. So this came directly from the data set. Our user ID, movie ID, rating, and timestamp. As well, the first column here is not actually officially a column. It's known as an index column, and that is just the count of the rows. So we have 100,836 rows by 4 columns. So here, each of the rows represents a rating. And then we have the ID of the user who made that rating. We have the ID of the movie, and we have the actual rating and the time stamp, which is the time that the rating was made as an integer, but that can be converted to a date time. All right, we can also rename these columns to anything we want. To do that, what I'm going to do is create here a ratings features variable, and I'm going to make a list of the new names I want for my columns. I'm going to use user ID, item ID, rating, make sure they're all strings, and timestamp. So just changing slightly the names of the columns is something you can do. You do have to then pass in here an argument names equals your ratings features. So now if I run this code cell, okay, we have here our columns have been renamed. Now you'll also notice that we get this first row now has been created that has the actual names of the previous columns. Well, we do have to remove that, so we have to drop the first row from the data frame. So this will be a good exercise in how to manipulate pandas data frames, which comes in handy quite a lot with data science and machine learning. So how do we drop that first row? Well, we're going to take the ratings data frame, and we're going to use the drop function. We're going to drop the ratings data frame dot index 0. So when we call dot index, we're getting the rows, and when we call index at 0, that means we're getting the first row. So I'm going to just extract that into a variable to make it more clear for you that what that 0 is. That 0 is the first index row, 0. All right, then we're going to override ratings data frame. So it's going to be the original ratings data frame, but with the first row dropped. And to prove that, I'm going to paste for you the variable name. Here we go. All right, so you can see that that first row has now been dropped. We're back to what we had before, but with different column names now. You'll notice here, some users are listed multiple times. That's because one user can rate multiple items or multiple movies. They don't have to just rate one movie only. They can rate multiple movies. All right, now, I also want to take my whole data frame and convert it to a different data type, because currently I can get some information about my ratings data frame with the function info. All right, and you'll see here some information. It's a pandas data frame, and we have all the columns, the non-null count for each column, and the data type of each column. And you'll see the data type is actually object by default, and we want to change that. Because if we have an object data type, then we can't perform the same math that we could on a numerical data type. So how do I take my whole data frame and convert the data type from object into float? Well, for that, I'm going to take ratings data frame and override it to ratings data frame dot as type, which is a function that will let you take the whole data frame and change its type. The type we're going to change it to is a float. We're not saying float 64, float 32, we're saying just a float. And then we can get ratings data frame dot info again, and we'll see that this time, look at that, we've converted all the data types to a float. We can also check the values, and you'll see this time they're all the same values, they've just been converted to a float, so they now have a decimal place. All right, great. Let's do the same thing with our second file here, which we have movies.csv. So I'm going to make a new code cell here, and I'm going to use pandas.readcsv. This time I am reading movies.csv instead of ratings.csv. And I'm going to save this as my movies data frame. All right, then I can paste the results of our movies data frame, and we'll see what we get. Okay, look at this. We have here our movie ID, our title, and the genres of the movie. Okay, great. Again, we could rename the columns if we wanted to. We could also change their data types. For example, here, let's grab movies data frame and check out what are the types of all of the data. Okay, the movie ID is an int64. The title is an object, and the genre is an object. Okay. That is fine. We could convert movie ID to a float, which we may require later on, because a lot of math and machine learning, they do require often floats instead of ints. So we may come across that later. As well, we can also remove any features that we don't need. For example, if we didn't want the genres, then we could remove that. And in fact, I'm going to do that. I'm going to remove the genres here from our data frame. So to do that, I'm going to create a new code cell here. And I'm just going to create an entirely new data frame for that. So we're going to continue on with that in the next lecture. Coming up, we're going to take the two data frames that we created and we are going to merge them together. So first we'll have to clean them up, remove any columns we don't need, and then we can merge the two together. So join me coming up in our next lecture where we will continue the data processing phase of our project. Hello everyone, and welcome back to our course. In the previous lecture, we loaded in our movies and ratings data, and we put them into the pandas data frame type. Coming up next, we are going to merge the two data frames together. So first, I'm going to remove any columns I don't need For example, I don't need the genres column for this particular project. So how can I take the genres column and remove it from this data frame? All right, well, first we're going to create a new data frame to store the subset of the original, and I will call this my movie titles data frame. I'm going to take the movies data frame and I'm going to specify which columns I want. And note that I'm doing this in double square brackets. Then I just have to pass in the column names that I want to keep. So what do I want to keep? I want to keep movie ID and title. So I'm going to pass in movie ID, comma, title. All right, then we can see the results of our movie titles data frame. Look at that. We have the same content, but this time we just have that last column removed. Okay, now as well, I do want to convert this movie ID type into a float, because currently if we use movie titles data frame.info, we can see that we have the default data types created by pandas, an int64 for the ID and an object for the title, but we can convert these. So I'm going to just convert the movie titles data frame to a float because that is going to be required by the techniques that I'm going to use in this project. So how do I convert just the one column to a float? In the previous lecture, we saw how we can convert a whole entire data frame into a float, but how do we just convert one column into a float? Okay, well, what we do is we take that data frame, movie titles data frame, and we grab the specific column we want, which ours is movie ID. All right, then we are going to assign that to equal our original data frame, movie titles data frame, at that same column, movie ID, but then we want to convert it to a float. So for that, we're going to first convert it to a string as type string, and then as type float. All right, then we can grab our results again. So we'll check info one more time of the data frame. And this time we'll see we have it converted to a float 64. Awesome, so we've been able to take that column and convert it to a float. All right, next up, we're going to merge the two data frames together, our ratings and now our movie titles. So let's create a new code cell and get started. We're going to use the function from pandas known as merge, which allows us to combine two data frames. Which two data frames are we combining? Well, we're combining our ratings data frame with our movie titles data frame. Then we have to pass in a third argument known as on, and this is on which column do we want to merge the two data frames. So if we look at the two data frames, we can see all of their columns. We have movie titles data frame and we have our ratings data frame. In fact, we could just do that in one by just showing here our ratings data frame.info so we don't have to scroll. Okay, we can see the different columns. Now, if we want to actually merge these two data frames together, then we have to take some common column that they have, and we have to make sure they have the same column name at that column. This is known as the key column because it will allow us to merge the two together. So currently our two data frames actually don't have any columns with the same name. However, they do have two columns in common, which is the item ID, which corresponds to movie ID. So what I want to do is actually change the name of item ID to movie ID. So let's go back up to the top of our project here. Okay, let's see. And let's load in our original data frame without the names. I'm just going to run this code cell. Okay, great. So we had movie ID there. So I'm just not going to rename the columns then. You can rename the columns, and sometimes you will have to, because as you just saw, if you have no common name, then you have to have a common name. And that's how you can create a common name, is by setting manually the name of the column. Then I can just rerun our code cells again in order to ensure that all of the code cells compile. Okay, this last code cell we have to fill in now. On what column do we want to merge the two data frames? Well, now look at this. Now we actually do have columns with the same name. We have movie ID and movie ID. All right, so I'm going to merge on that column. I just pass in the column name, movie ID. Make sure you spell it and capitalize it exactly correctly. And the result is going to be our merged data frame. So I'm going to create a variable merged data frame to grab the result. Then I can paste out my merged data frame. And look at this. Now we have our two data frames combined. We have user ID, movie ID, rating, timestamp, and the title of the movie that corresponds to the rating. So we took our ratings, which was the first 4 columns, and we just added another column to it effectively. This title that corresponds to the movie ID. Awesome. Okay, great. So now we have our merged data frame. Next, we are going to see how many ratings we have per movie. So I'm going to make a new code cell, and I'm going to grab my merged data frame and use the function group by. I'm going to group by the movie ID at my rating column and use the count function to get the number of times that the value appeared. So the number of times we have an actual entry for each movie. Then I'm going to use, well, I can also sort to get my results if I want to see which one had the highest. Okay, look here. So now we have 1, 2, 3, 4, 5. This corresponds to the movie ID all the way to the very end here. And we have the number of times that the rating appeared. We can also sort this if we wanted to. Here we could use sort values, run this code cell. That will sort it by default in ascending order. So now we have the fewest instances first and then the largest number of instances at the end. If we want it in reverse, then we just have to pass in an ascending argument and pass it as false. So that will give us descending instead. Just make sure that false here is in title case, because false is a Boolean. It's not a string or a variable. It's just a Boolean. All right, so here we can see that the movie with the ID 356, that had the most number of ratings with 329. The next movie was 318 that had the next highest number of ratings, 317. So this is how we can group our data frame by any columns we want, such as the rating, to see which movies are the top rated. All right, next up, we're going to continue processing our data for our recommender. So coming up next, we're going to create a rating crosstab. Join me in our next lecture where we will continue the project. Hello everyone and welcome back to our course. In the previous lecture, we merged our two data frames together, so now we have one master data frame. In this lecture, we're now going to prepare our data for our recommender, and the type of recommender that we're going to build is going to use a correlation matrix. So first, we have to build out a crosstab, which is a table that shows us the relationship between different variables. So let's jump back into our Colab and get started. I am going to take our merged data frame and use the function pivot table to create a pivot table out of the data. I'm going to pass in here several arguments. First, the values that I want to use for the pivot table. I want to use the rating column. Then the index that I want to use, which is the user ID column. Make sure you capitalize that exactly as it is here in camel case. Then as well, we want to pass in the columns that we want to use, which are going to be our title here. And finally, a fill value, which will just have 0. All right, the result here is our crosstab. So let's create here a variable. I'm going to call this crosstab and assign it to equal my pivot table. Then I can paste out for you the crosstab and we can see the results that we get. All right, here we go. So look at this. We have several rows and columns, 610 rows by 9,719 columns. So first we have our user ID, and then we have this table of zeros. At the top, we have the title. So here we have the title of each of the movies in our data set, and we have filled with zeros. Now I'm going to create my X for my correlation matrix. And to do that, I'm going to transpose this column. So I'm going to take X, define X, which is going to be my cross tab. Okay, my cross tab dot T. That's just transposing it. So flipping all of the columns and the rows. So now we have here the columns are the title and the user ID is the columns are the user ID and the rows are the title. So we're just transposing it. And you'll see why we have to do this coming up, because now we are going to build out our correlation matrix. All right, so for that, I'm going to use a class known as truncated SVD. This comes from scikit-learn. SVD is short for singular value decomposition, and we use it in order to reduce dimensionality of our data. So let's create a new code cell, and we're going to import from scikit-learn.decomposition. We are importing the truncated SVD class. All right, then we're going to put that to use by instantiating it. So I'm going to instantiate the truncated SVD. I'm going to pass in several arguments here. First, my number of components. So let's extract that to number of components. This is going to be, initially we can use 12. And as well, a random state. We can just set this to 1. Okay, the result of this is going to be our SVD object. So we can call this singular value decomposition. Okay, so now we have an object with that. Now we can actually take this object and use the fit transform function. So we're fitting the SVD through our data. Our data is X. The result is going to give us a matrix, or correlation matrix. And we can paste out the results that we get. Let's run that code cell and look at this. We get this array here of values. So here, this is just an array of values. Now, this is just the matrix really. If I want to make it a correlation matrix, then I have to use the function correlation coefficient. So let's do that. I'm going to use NumPy to write the algorithm for me. So import the NumPy library. NumPy is very commonly used because it has a lot of functions specifically for data science and machine learning. So I'm going to use the function correlation coefficient, coef, and I'm going to pass in my matrix that I created. The result now, that is actually the correlation matrix, because we now have the correlation coefficients there. So if I run this cell, here we go. We now have, again, our multidimensional array, but this time we're just getting the correlations instead of the actual results of the fitting, which would be the Y. We're getting just the coefficients there. Okay, so that is our correlation matrix. Coming up, we can actually put it to use. So we're going to use this correlation matrix, which is going to act as our recommender, and we're going to use it to find which movies are similar to a movie. So we can use this correlation matrix already to start making recommendations, because this correlation matrix, it was created out of our user ratings. So we'll be able to see where the movies had similar ratings. We're going to recommend those to be considered as similar to a certain movie. More on that coming up in the next lecture, where we are going to test our recommender. Hello everyone, and welcome back to our course. In this lecture, we are going to finish up our project by testing out our recommender. All right, so for that, let's first grab a sample movie, and we are going to find which movies have the highest correlation to it. So let's make this example movie variable. I am going to grab a list of all of our movies. So to do that, I have to grab my movies list, which is going to be a new variable that I create. So let's define movies a list. To do that, we are going to create a Python list with the list function. And then we want to get all of the movie titles that we have and put them into a list. So how do we get all of our movie titles? Well, what we can do is we can just grab them from the X that we had here, because you see we have a title for each of these. We can also just get it from our crosstab. Yeah, this crosstab right here, either the X or the crosstab. So if I'm using the crosstab, then just make sure you note that it hasn't been transposed. So in the crosstab, the titles are actually going to be the column. If you use X, the rows are going to be the title. So keep that in mind. You can also just grab it from the original data frame as well. You can just grab the column. I'm going to use the crosstab. So I'm going to define movie titles by grabbing my crosstab.columns. So it's a very easy way. Then I can just paste out movie titles first to verify that we indeed got what we wanted. Okay, great. Look at that. We get all of our names of our movies, the titles, as a list of length 9,719. Okay, so this is going to be here an index object. If we want to actually make it into a list, that's why we wrap it in the Python list function. So you'll see we're taking the index and we're just converting it to here, an actual list. Okay, so let's pick one of these movies that we have here, of which there are quite a lot. So for example, let's choose Batman Year One. Okay, now how do we take Batman from this movies list? Well, all we have to do is I'm going to use the index function and get the index of Batman Year One. So this is actually example movie index. All right, because I'm using this index function. The reason is I don't actually want the movie title. I have the movie title. I want the index of where the movie is in our list. And you can put in any movie that you want. Then we can verify the index just by pasting that variable. Okay, now you do have to make sure that it is in the list. So let's see. Yes. You have to also make sure you include the year, because the year, that is part of the name of the title, and make sure all the spaces are exactly the same as well. Then you'll get the index of our example movie. And again, you can use any movie you'd like. So now, how do we get the movies that have the highest correlation to our example movie? What we're going to do is use our correlation matrix, which we created in the previous lecture, and we're going to grab at the index of the example movie index. The result of this is going to be our example correlations. And I can paste out for us the values. We have this array. I need to take all of these array values and actually convert them into titles. So to do that, I'm going to use the list function, and I'm going to grab my movie titles. Then I'm going to grab where my example correlations are less than our maximum. So let's define this maximum. That is 1.0, because we can't have a correlation higher than maximum. So let's call this our maximum correlation. If we have a 1-to-1 correlation, that means we have a perfect match. And as well, we want to use here the AND operator to also check where our example correlation is greater than a minimum correlation that we must require. So that means we want to only show where we have some kind of minimum met, for example, 0.5. All right, we have to make sure we define example correlations. Oh yes, just make sure it's plural. And then we can run that code cell. And here now we have the top 50% of the correlated movies. If we increase this number, for example, to 0.85, then we'll get fewer movies here. If we increase it to 0.9, again, we'll have fewer movies. Okay, so this is going to be the top 10% of movies that were found to have a correlation with our example movie. And that means that we would recommend these movies to users who liked our example movie. And just like that, we have built out a recommender that's able to provide recommendations using this correlation matrix that we built with our tactic that involves singular value decomposition. Congratulations, everyone, on completing this project. I'm excited to see where else you go from here. You can expand this project by increasing the amount of data you have. The data that we used came from Movie Lens, and it was the smallest or the smaller data set, but you can use the larger version. For example, at the top here, you can see we're using ML latest small, so it's just a smaller version because it will run faster, but you can use the ML latest version, which is the entire data set, not small, and it has a lot more ratings. Currently, we still have a lot. We still have 100,000, but if you're interested in trying out the project on more data, then definitely continue with that. I will see you in another course. Hello, everyone, and welcome back to our course. In this lecture, we're going to begin building out our simple movie recommender with machine learning. The first step is going to be to load in our data from our data set to pandas data frames. So the link for the data is from grouplens.org. I've also included it for you in the source files for this section. It's the same one that we'll be using in our projects, and it contains movies.csv and ratings.csv. So it contains a data set about movies and about ratings from users of those movies. And here is the credit for the creator of the data set. It was actually scraped from the Movie Lens site. All right, so click on this folder tab here in Google Colab at colab.research.google.com. You can run one of the code cells in order to enable the runtime to connect. Here, Google Colab is a free online Python editor, which means we can code in Python without downloading or installing anything. All right, and we're going to drag in our dataset files. So go to either the data lecture of this section or to the source files lecture. In both places, you can find movies.csv and ratings.csv. And just drag those two files right here into the Colab. You'll get this reminder that uploaded files do get deleted when the runtime is recycled, which means if you refresh the page, you'll have to re-upload these files. All right, so now we have the two CSV files available for us to use here in Google Colab. So let's go ahead and put those to use. We have to take them from the CSV data type and convert them to a pandas data frame. So let's create a new code cell here, and we're going to import the pandas library. Now, the pandas data frame type is very commonly used to convert data from a regular format like JSON or CSV, because the data frame is much faster and it has a lot more functions to help you out. So we're going to use the function read CSV. This comes from pandas, and it takes a CSV file and converts it to a data frame. In here, we have to pass in the path to one of our files. For example, let's start with movies. I'm going to pass in here movies.csv. That is the path to movies.csv here in Colab. That's just because the file is directly here in files. If I had it in a subfolder, then it would have to have the path to include the subfolder. All right, so the result of this is going to be a movies data frame, and I can paste out the variable to prove that to you. Look at this. Here is our movies data frame. So this is just movies.csv, the spreadsheet, converted to a data frame type. We still have rows and columns, but it's just a different data type. First, we have the index column, not officially a column. It's just to count all the rows. Then we have a movie ID column, which is unique to each movie. Then we have the title of each movie and the genres that the movie falls into. All right, awesome. Now, we can actually take this index and we can convert the index to use a different value. For example, we could use date time or a date as the index. We could also actually use any column in the data frame as the index column. So I'm actually going to change the index column to use movie ID. To do that, let's make a new code cell, and I am going to grab my movies data frame, and I'm going to use the function setIndex. So already you can see, because we're using the pandas data frame type, we have access to a lot of functions such as setIndex. In fact, you can find all the functions by going to the documentation for the pandas data frame class. All right, here we have setIndex. We can take any column and use it as our index. I am going to use movie ID as our index, and I'm also going to pass in place to equal the Boolean true, so capital T. And this means that I'm going to actually change the data frame in place, so I don't have to resave it. It will be changed. I can run the code cell and look at this. Now our data frame looks slightly different. Can you spot the difference? Well, our movie ID column is now not officially a column. It's actually now the index column. So in fact, the number of columns in our data frame has changed from 3 to 2 because the movie ID column is now known as the index. It's not actually a column. But we still have title and genre. Those are official columns. All right, let's also now bring in our second CSV file. We have ratings.csv. So I'm going to create another code cell. And this time I'm going to use pandas.readCSV again, but I'm passing in a different path. The path to my CSV file now is ratings.csv. And the result is a ratings data frame, which we can paste out and we'll see our results. Here we go. Okay, again, we have this data frame type. There are a lot more rows this time, 100,000 rows, because there are more ratings than there are movies. All right, we have the index column counting off the rows. Then we have the user ID column. This corresponds to the user that did the review. Then we have the movie ID column. This corresponds to the movie that the user is rating. Each row here is a new review. Then we have the rating column, which is the number out of 5 that the user gave to the movie. And we have the timestamp, which is an integer, but it can be converted to a date time, which is when the user made that review. Awesome. And just like that, we have loaded in our data sets. Join me coming up in our next lecture, where we're going to learn how we can use different movie features to make a recommendation to our users. Hello everyone, and welcome back to our course. In the previous lecture, we loaded in our data, and in this lecture, we're going to learn how we can use different movie features to make a movie recommendation to a user. So let's create a new code cell continuing on here in our Colab file. All right, first, let's make a recommendation just based on movie ratings alone. So I'm going to grab my ratings data frame, and at the index of movie ID, so I'm going here into ratings data frame, and I'm grabbing that movie ID index or key, which just means I'm getting that column. So I want this column of movie ID. I want to grab where value counts is unique. So here I have the value counts function. This is going to tell me how many times that movie ID appeared. The result of this is going to be our total counts. All right, and I'm going to paste out for you total counts, and you'll see here. All right, so we have our key here being the index or ID of the movie. And then we have the value being how many times that movie was rated. So the movie with the ID 356, that was rated the most times with 329 just by this list. But note that this isn't actually in descending order. So it's not necessarily that this one is the highest. It just appears to be the highest, but there are actually 9,000 hidden rows here, so they could be higher. And you can sort the total counts if you want to see the highest ones. For our purposes, it's not really relevant. We just need to know that total counts is a dictionary that has the ID of the movie and then the number of times it was rated. So some movies were rated 300 times, some movies were rated just 1 time. All right, and now I'm going to actually create a new column in my movies data frame. So let's grab movies data frame. To create a new column, you just act as though the data frame is a dictionary, and you create a new key or a new entry. So all you have to do is reference the column even if it doesn't exist. So if the column doesn't exist, for example, I have here my movies data frame. Let's say I want to add in a total ratings column. If I don't have that, I can just reference it and it'll just be created. So I'm going to create here total ratings, and you could also call this ratings count, just to make it clear that it's how many times the movie was rated. And I'm going to set it to equal total counts. So this means that it's going to be populated with total counts. All right, then I can paste out our movies data frame and we're going to see our results. So we didn't just go down the list of total counts, we actually went according to the movie ID. So with ratings count, it's going to match all of the movie IDs with the ratings count and put that into the appropriate row inside of our movies data frame. So look at this. Now we have this new column, ratings count, and it tells us how many times the movie was rated. Awesome. Okay, now we can sort this data frame and we can find which movies had the highest count. So I'm going to make a new code cell here. I'm going to grab my movies data frame and I'm going to use the function sort values. Then I can pass in the column name that I want to use to sort. I'm going to use ratings count, make sure it's a string, as how I want to sort the data frame. Then I can paste out the data frame results. Okay, and if I just paste out the variable name, it's actually not going to change the data frame itself. So when you call sort values, you're not actually changing the data frame. Instead, you are getting a preview for yourself here. So you have movies data frame, then you're calling sort values ratings count. So you're going to have here from 1 all the way up to the largest value, because by default, you'll have it sorted in ascending order, and the largest value is considered not a number, which means that the movie was actually never rated. If you want to see it in reverse, if you want to see the highest values first, then you call ascending to equal false, and that is going to put for you, this time, instead of having the sorting in ascending order by default, it's going to have it in descending order. So now at the top here, you actually do see the highest ratings. Okay, so it also happens to be the same as total counts, but this might not always be the highest values, keep in mind. All right, so here we can actually see our ascending is equal to false, which means we now have sorted by descending order and not a number. Again, it's just put dead last. So whether you have ascending or descending, not a number, any null values will be put last. And you can actually remove those as well if you want to clean up your data. We can also get the first several entries. For example, if I want to call the first 10 entries, I just have to call dot head 10. And I'm just going to extract 10 so you know what it means. It means segment length, and I'll set it to 10. Then if I rerun this code cell, it's going to show me the first 10 of the most often rated movies. So here we have the top 10 movies that were rated the most number of times. Starting with Forrest Gump, that was the number 1 most rated, then The Shawshank Redemption, Pulp Fiction, etc. Awesome, okay. So that is how we can find which movies were rated the most number of times. If a movie was rated more often than that, means that it has a higher popularity. So this is one feature that you can use to make a recommendation, because if a movie was recommended a lot of times or rated a lot of times, then that means it's more likely to be watched because it's popular. So that is one feature that can help you to make a recommendation. Another feature is average rating. So we can actually create a new column in movies that can show the average rating for a movie. So let's add that. Let's add a new code cell. I'm going to grab our ratings data frame, and I'm going to use the function group by. I'm going to group all of my ratings by movie ID. So this means that I'm going to put together all of the ratings that were for the same movie. And I can run this code cell here. This is a data frame. I just want to show you an example here. So I'm going to paste out example. All right. So we have this data frame group object, and I can call, well, I can't call info because it's not a data frame. But let's keep going. So this is going to group all of the ratings into groups based on their movie ID. So if they're in the same group, it means they have the same movie ID. Then we can use the function mean to get the average. Now, what are we getting the average of? We're getting the average of the rating column. So we do have to specify what column we want to use to get the average. And this is the syntax for doing that. You call .mean followed by the column that you want. So this will give us the mean, otherwise known as average, of the rating column. And we have groups of the same movie. So the results, we're going to save this as average ratings. All right, then I can paste out average ratings because it's now going to be here, this series. So we have our movie ID. Then we have the average rating for that movie ID. Now let's place that into our movies data frame. At a new column, we'll call this our average rating. So we're creating a new column again, and I'm going to populate it with average ratings. So yes, you can take average ratings here, which is a series, and you can put it into the data frame. So you can take this series and put it into the data frame at a certain new column. Then I can paste out movies data frame to verify that we do indeed have this new column. And look at that, we do. We have this new column called average rating, and that tells us our rating of the movie on average by the users that actually rated it. So now we have actually two features that we could use for recommendations, two new features, ratings count and average rating. So which one should we use to recommend a movie? Should we use the number of times that a movie was rated, or should we use the average rating? Well, the answer is that we can actually use both. We don't have to just pick one feature. We can use multiple features to determine what we should recommend a user, and that's exactly what's done in the real world. A lot of different features are used to recommend you something like a video or a movie. So let's sort our data frame by these two features this time. So I'm going to make a new code cell. I'm going to call movies data frame, and I'm going to use the function sort values again. Note that you're not actually changing the arrangement of rows when you call sort values. You're not actually changing movies data frame. You are just seeing the new sorted data frame if you were to sort it. You could override the value and sort permanently, but for our purposes, we're just sorting temporarily to see what would happen if we wanted to save the new rearrangement of the rows. So I'm calling sort values, but this time I want to use two columns. I want to use ratings count, and I want to use average rating. Now, because we're using two column names, we actually have to pass this as a list. So we can't pass in two of our strings, that we have to pass in a list. That's required by the sort values function if you want to sort by two columns. Then we can run our code cell again. Again, by default, we have our movies data frame in a sorted preview of ascending order. But we can add here, after the list, we can pass in an ascending argument and set it to false. By default, it's true, but if we set it to false, then look at this. Now, we are sorting by ratings count that is highest and average rating as well. Let's say we only wanted to do average rating here. Well, look at this. Then this time we're only sorting by the top average rating, which would be 5.0. But by adding both, we're actually taking both into account. So instead of using just one, like ratings count, we are putting in both. And we can see the top 10 with segment length. Here we can run this code cell. Okay, and I am going to just compare that here. So our results are quite similar to our initial data frame where we just sorted by ratings count. All right, as well, we can use any combination of values. For example, we could use mean rating or average rating, and we could also make sure that the minimum number of voters was a certain value. So for example, you could only recommend a movie if there was a certain number of votes on it already. That's something that you could take into account. So let me show you how to do that as our final example in this lecture. So I'm going to grab our movies data frame and I'm going to use another function known as query. Then I can pass in here a formatted string of my query. So I want to find where the ratings count was greater than or equal to some minimum. So I'll call this minimum ratings count. Then let's define a minimum ratings count. Let's say perhaps 100. All right, and then after that, I'm going to be able to see that my data frame query is going to be smaller. So I'm going to just save this as my minimum ratings subset. Then I'm going to paste out the results of minimum ratings subset. And look at this. Now we only have 138 rows by 4 columns because now we have made sure that we only consider data frames that have a minimum number of ratings of 100. If they had less than 100 ratings, we didn't even consider them to be recommended. All right, and again, we can also just append anything we want here. For example, we could sort, again, by one of these columns, such as our ratings count. So we can just add that right there. And now we're going to be sorting by ratings count. The minimum is 100 this time, not 1. The maximum is still the same, but the minimum has changed. And we can make this any query we wanted. So you can use different queries to have very specific recommendations. Awesome. And that is how you can use different features to find which are the top movies to recommend. Coming up, we're going to learn how we can recommend a movie to a user based on what the user previously watched. So join me coming up in our next lecture where we will work on that.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle. And it's on sale today. So buy before the sale ends. Thanks for watching and I'll see you in another video.